Every mechanic in America is making the same mistake when a customer rolls in with a rattling suspension. They throw parts at it. New end links, new bushings, new struts, and 6 months later the rattle comes back. I know because I used to do the same thing. For years I would swap in new sway bar bushings, charge $250, and feel good about myself. Then the customer would be back in my shop 8 months later with the exact same clunk, same corner, same sound, same frustrated look on their face. And I would replace the same parts again. It was not until I spent time studying how Japanese manufacturers actually engineer and maintain suspension systems that I realized why. The problem was never the parts. The problem was how we were installing them. There is a method the Japanese car companies have baked into their factory service manuals that almost nobody in the American aftermarket follows. And it is so simple that when I explain it to other mechanics, they get angry at themselves for not figuring it out sooner. Today I am going to walk you through this method, step by step. It is not one fix. It is a 5-step system rooted in a Japanese engineering philosophy called Kaizen, which translates to continuous improvement. Toyota built their entire production empire on it. And when you apply that same thinking to your suspension, you stop chasing rattles and start eliminating them permanently. I have been using this system in my shop for the last 4 years. In that time, my suspension rattle comeback rate dropped from about 30% to nearly 0. Let me show you how. Step 1. Diagnose like a Japanese engineer, not an American parts swapper. Here is what happens in most shops when you come in with a front-end clunk. The technician puts it on a lift, grabs the sway bar, shakes it, hears a noise, and writes up new sway bar bushings and end links. That is American troubleshooting, fast, profitable, and wrong about 40% of the time. Japanese engineers use something called the 5 whys. Toyota made this famous in their production system, and it works just as well under your car as it does on an assembly line. You ask why 5 times, and each answer takes you deeper toward the actual root cause of the problem. Let me give you a real example from my shop. A guy came in last year with a 2016 Subaru Outback. Annoying clunk from the front end, mostly at low speeds over bumps and potholes. He had already been to 2 shops. The first one replaced the sway bar end links. That was $180. The clunk came back in 3 months. The second shop replaced the sway bar frame bushings, another $160. The clunk came back in 6 weeks. He was furious. I applied the 5 whys. Why is the front end clunking? Because the sway bar is moving in its bushing mounts. Why is the sway bar moving when it has new bushings? Because the bushings are not clamping the bar tightly enough. Why are new bushings not clamping properly? Because the sway bar itself has worn grooves where the bushings sit. The bar's outside diameter at the bushing contact point had decreased from wear. Why did the bar wear down? Because the original bushings had dried out years ago and started allowing micro-movement, which slowly scored the bar surface. Why did no one catch this earlier? Because both previous shops only looked at the bushings and never inspected the bar itself. The actual fix was not new bushings. It was addressing the worn bar. I cleaned the contact area, built up the diameter slightly with 2 wraps of high-quality PTFE tape, installed properly sized new OEM bushings, and greased the contact surfaces with a silicone-based lubricant. Total cost: $35 in parts and about 45 minutes of labor. That was 14 months ago. He texted me last week. Dead silent. No rattle, no clunk, nothing. 2 shops and $340 could not fix what $35 and the right diagnostic approach solved permanently. Step 2. Torque at ride height, not in the air. This is the single most important thing in this entire video. I guarantee you, 80% of the shops in this country are getting it wrong. When you replace control arm bushings, sway bar end links, or any suspension component that uses a rubber bushing. Those bolts must be torqued with the suspension loaded at ride height, not with the car up on a lift, not with the wheels hanging in the air. At ride height. This is standard procedure in every Japanese manufacturer's factory service manual. Toyota, Honda, Mazda, Subaru, all of them specify this clearly. And yet I watch mechanics every day torque these bolts with the suspension hanging at full droop, and then wonder why the car rides harsh and the bushings fail early. Here is the engineering reason. A rubber bushing is bonded between an inner metal sleeve and an outer metal sleeve. When the bolt is tightened, it clamps the inner sleeve to the subframe or bracket. The rubber cannot spin. It can only deflect, and that deflection is what absorbs vibration and allows controlled movement. If you torque that bolt while the suspension is hanging at full droop, the bushing is now in its neutral, unstressed position at full extension. When you lower the car and the suspension compresses to ride height, the rubber is already pre-twisted. It is being loaded before the car even moves. Every bump, every turn, every pothole adds more stress on top of that preload. The rubber tears internally. The bond between the rubber and the metal sleeves starts to delaminate. From 6 to 12 months, you have a bushing that looks fine on the outside but has completely failed internally. I tested this myself. I replaced both lower control arms on a 2015 Honda Civic. On the driver's side, I torqued the inner pivot bolts at full droop, the way most shops do it. On the passenger side, I used a floor jack under the knuckle to simulate ride height before torquing. Same parts, same torque specs, same car. At 18 months, I pulled both sides. The driver's side bushing showed visible cracking and separation at the rubber-to-metal bond. The passenger side looked nearly new. Same car, same roads, same driver. The only variable was when the bolts were tightened. If you are doing your own suspension work, here is how to do this properly. Get the car on jack stands under the frame. Leave one corner's wheel off. Place a floor jack under the lower control arm or the brake rotor. Jack it up until you reach the measured ride height, which you can check by measuring fender to ground before you start the job. Then torque the bushing bolts to spec. Drop the jack, move to the next corner, and repeat. It takes an extra 20 minutes. Those 20 minutes will double or triple the life of every rubber bushing on the car. Step 3. Use the right lubricant and never use the wrong one. Japanese engineers are obsessive about material compatibility. This is where the American aftermarket gets people into serious trouble. Most guys grab whatever grease is on the shelf. Lithium grease, white grease, chassis grease, even WD-40. Every one of those will destroy a rubber bushing over time. Petroleum-based lubricants cause a chemical reaction called swelling in rubber and polyurethane. Hydrocarbon molecules penetrate the polymer structure, soften it, and eventually cause the bushing to deform and fail prematurely. I have pulled bushings out of cars that looked like melted cheese because someone sprayed them with penetrating oil, thinking they were helping. Here is the correct approach, and this comes directly from the engineering specifications the Japanese manufacturers follow. For original equipment manufacturer rubber bushings, the best option is a silicone-based lubricant or a dry silicone spray for temporary noise relief. Rubber bushings are designed to deflect, not rotate, so they generally should not need heavy lubrication. If an original equipment manufacturer rubber bushing is squeaking, it is usually telling you it is failing and needs replacement, not grease. For polyurethane aftermarket bushings, use a silicone grease with PTFE additives. Polyurethane bushings are designed to float and rotate on their sleeves, and they absolutely require lubrication to function quietly. Products like Superlube, silicone grease, and Energy Suspension Formula 5 are specifically formulated for this. They are tacky enough to stay in place and slippery enough to prevent binding. The key rule is simple. If it is rubber, silicone only, no petroleum products ever. If it is polyurethane, PTFE silicone grease applied generously to every contact surface during installation. I keep both in my shop, and I label them clearly so nobody grabs the wrong one. This alone has eliminated probably 60% of the squeaking comebacks I used to deal with. Step 4. Inspect what everyone else ignores. Here is where the Kaizen mindset really separates good suspension work from great suspension work. When a Japanese factory service manual tells you to replace a bushing, it also tells you to inspect a list of related components. The manual does not assume the bushing is the only problem. It asks you to look at the whole system. Most American shops skip this entirely because it takes time and does not generate additional labor charges up front. When I do a suspension rattle repair, I inspect 7 things every single time, regardless of what the customer came in for. First, the sway bar surface where the bushings contacted. I am looking for scoring, grooves, or diameter loss. If the bar is worn, new bushings will not grip it properly, and the clunk will return. Second, the end link ball joints. I grab each end link and check for play. Even a small amount of play in an end link will transmit as a noticeable clunk because the sway bar amplifies the movement to the opposite side of the car. Third, the control arm ball joints. Load them by jacking under the lower arm and look for movement at the joint. A worn ball joint can mimic a bushing noise almost perfectly. Fourth, the strut mounts. A worn upper strut mount bearing will pop and clunk over bumps and is commonly misdiagnosed as a bushing issue. I check this by putting my hand on the spring while someone turns the steering wheel. If I feel a catch or a pop, the mount is going bad. Fifth, I check every bolt for proper torque, not just the ones I am working on, but every fastener in the system. A single loose bolt on a heat shield, a subframe mount, or a splash guard can create a rattle that sounds exactly like a suspension issue. Sixth, I check tire wear patterns. Uneven tire wear tells me the alignment is off, which means something in the suspension has shifted or worn beyond its designed range. This is often a clue to a worn bushing that has not started making noise yet, but will soon. Seventh, I look at the shock absorbers. A shock that has lost damping ability allows excessive suspension movement, which puts more stress on every bushing, link, and joint in the system. Fixing a bushing rattle without addressing a blown shock is like mopping the floor while the faucet is still running. This 7-point inspection adds maybe 15 to 20 minutes to the job, but it catches problems before they become noises, which is the entire point of the Kaizen approach. You are not just fixing today's problem, you are preventing next month's problem. Step 5. Replace as a system, not as individual parts. This is the final piece, and it is the one that saves you the most money in the long run. Japanese engineers design suspension components to work together as a system. The bushing durometers, the link lengths, the bar diameters, the spring rates, they are all calibrated to complement each other. When you replace one worn component and leave the others, you create an imbalance. I see this constantly. Someone replaces the front sway bar bushings but leaves the original end links that have 80,000 miles on them. The new tight bushings now transfer more force into the old loose end links. The end links fail faster than they would have otherwise. And now you have a clunk again, just from a different source. Or someone replaces one control arm bushing on the driver's side, but not the passenger side. The car pulls slightly, the alignment is off, and both sides wear unevenly. The Japanese approach is to replace suspension components in complete sets, both sides at once, bushings and links together. And when you hit 80,000 to 100,000 miles on most vehicles, consider doing a full bushing refresh. Every rubber bushing in the front suspension, both sides at the same time. On most Japanese vehicles, the parts for a full front bushing kit run $150 to $300. A qualified independent shop will charge 3 to 5 hours of labor. Call it $600 to $900 total. That sounds like a lot until you compare it to replacing individual bushings one at a time over the course of 3 years. I have customers who spent over $1,500 chasing individual rattles, part by part, visit by visit, when a single comprehensive job would have cost them half that and lasted 3 times as long. Here is my checklist for the full bushing refresh. Lower control arm bushings, both inner and outer. Upper control arm bushings, if your vehicle has upper arms. Sway bar frame bushings, sway bar end links, strut mounts and bearings, tie rod ends if they show any play at all. And while you are in there, new hardware, new bolts, new nuts, and new cotter pins. The old hardware has been torqued, corroded, and stress cycled for years. Fresh hardware torques more accurately and holds better. One of my favorite customers, a retired teacher with a 2014 Toyota Camry, came to me at 94,000 miles with a laundry list of small noises. Little clunk here, subtle creak there, slight vibration at highway speed. 3 different things that 3 different shops would have billed as 3 separate repairs. I did a complete front suspension bushing refresh. Every bushing, both sides, new links, new strut mounts, fresh alignment. Total bill was $820. She drove out of my shop and called me that evening. She said the car felt like it did when she bought it. That was 2 years and 30,000 miles ago. She has been back for oil changes and tires. That is it. 0 suspension work, 0 comebacks, 0 rattles. That is the Japanese method. It is not one magic trick. It is a system. Diagnose the root cause before you touch a single bolt. Torque everything at ride height so the bushings live in their designed operating range. Use the correct lubricant for the correct material. Inspect the entire system, not just the squeaky part. Replace components as matched sets so the system stays balanced. If you have been chasing a suspension rattle that keeps coming back, there is a very good chance one of these 5 steps was skipped. Go back through them. I would bet real money the answer is in here. This is the same approach that makes Japanese vehicles the most reliable on the road, applied to how you maintain them. It is not about spending more money. It is about spending money once, correctly, and never having to think about it again. If this kind of straight talk saves you time and money, hit subscribe. I have more videos coming on the maintenance mistakes that cost people thousands, and the simple fixes that the dealerships will never tell you about. If you want to know which suspension parts are actually worth upgrading versus which ones are a waste of money, I did a whole video on that. It is right here. Like if it helped. Drive safe. Take care of your car and it will take care of you. Take it or leave it. I will see you in the next one.